Hi everyone. My research question is, in what ways can natural language process be applied to the auto-generalization system for BIM names in an architectural project to eliminate repetitive tasks? New digital technologies often lead to the development of new solutions for existing problems. For example, social media technologies led to social media network, which triggered the development of social media marketing concepts. So digital transformation is also impacting the architecture industry, most notably in relation to the uptake of building information modeling approaches in the production and delivery of architectural projects. In the first part, I'm going to introduce what's building information modeling, what's the benefit of cloud cooperation in BIM-based projects, and the challenges of using BIM. Building information modeling BIM is an information model that's composed of completely sufficient information to support lifecycle management, which can provide the obtained models and their parameters. Since the decades of development of BIM, it is common to see the use of mobile devices to access cloud BIM models at construction sites. Also, multidisciplinary actors can have a deeper cooperation online through their transparent information sharing. However, the lack of unified stand in classification of BIM objects increased the difficulty of find target information in the BIM model. Imagine that you are a quality supervisor on the construction site. The workers just finished building the toilet. Now you are going to access the BIM model to check the details of it. So you type in toilet in your device. It appears a lot of results, but none of these are your target room. Then you may spend a lot of time to find the target information. Then finally, you find that the room tag of your target toilet is John, which is an informal name of toilet. This situation may get worse when the BIM model was created by the people from different nations, which means the annotation of each BIM object will be named by multi-languages. As you can see, items in the right side are stuck in a mess, making it difficult to find. BIM originally is introduced to increase the efficiency of communication between users, but in this situation, the efficiency of using BIM seems still slow. To solve this problem, I'm going to introduce an auto-generalization system for BIM names, talking about its objectives, how natural language process assists the system, and the outcomes. So the first target is to save the BIM user's time of finding target information, and the second is to reduce the omission compared to the manual finding process. Our problem is that there's a lot of different words are describing the same meaning. In this case, natural language process can be introduced into this finding process by building an auto-classification system for BIM objects. NLP is a subfield of artificial intelligence, which studies the theories and methods that can achieve effective communication between humans and computers. By using walk-to-vector, which is using words as vectors to calculate and extract a neutral network of words. For example, this is the vector king and vector man. According to the rule, it can be found that this is king minus man vector and this is vector woman. So we can get king minus man plus woman equals queen, which can help computer understand the relationship between each word and get a simpler definition. Let's see another example. Coach. Coach has a meaning of teacher in the sports area. So sports can be an important attribute of the results. With Andrew, we defined 5 important classifications. First, location. Second, size or relation. Third, sector. Fourth, ownership. And fifth, function. Now I'm going to introduce my workflow of the project. Since this system will be used in architecture field, the first step is to identify the function words in the phrases. So I find all the words meaning like room, space, facility, and find their more general callings as function list. Then I find 5 adjective words can describe the items in the function list, which are the SR list. And I find 5 antonyms of each items to enlarge the dataset and delete the duplicate data and the null data. By analyzing the sample CSV files, I found that the ownership vector is related to the occupation. For example, staff list, coach office. Then I find a occupation dataset from GitHub and use entity recognition in natural language process field to quickly find all the entity of occupations. Then I append them into a list as our ownership list. Now let's see how the prototype works. You can choose multi-files into the system and the program will return new CSV files which contain 5 vectors as our expect. So the workflow of the program should be: first, upload the Revit files. Instead of import CSV file straight away, extract the CSV file from the Revit file. Then import the data we need and clean the direction words, useless description words, and the null item in the dataset. By analyzing the original files from the Revit, there's a colon department, which is describe the sector of each room, so I matched it with the names of each BIM object and append them as our sector list. Then I detected each part of names of BIM object in the list we create from the pre-production stage and return full result vector information into result library. Another location information for now is just detecting the words external, internal, and shortcut of them to judge the location condition. The result I showed here is extract from the prototype result. As you can see, female officials wet area. The location information for now is null. Sector is amenities. Size and relationship is female. Ownership is officials and the function is wet area. To test the system, I used a BIM project from Cox, which created in 2017. And by randomly choose 100 results, and if one of the 5 vectors is wrong, I marked whole result as wrong. And repeating the whole process 4 times, we can have an average accuracy at 82%, which is actually pretty high. For the future work, I'm now making whole function as a search engine plugin in Revit, and the plugin still has some bugs, so that I cannot show it until I figure out how to fix them. But I'm going to present the process of making it. So firstly, I'm using Revit Python shell, which is an Iron Python console that runs inside of Revit, and using PyRevit, which allows users to create their own scripts. So this is the script, and we use WPF to get access to the XAML or WPF engine, and we will give it the path of this UI XAML file we created, and the engine will load it up and generate the components for the window and everything else. But before that, it needs to have access to the class myWindow, which also needs to be provided to the engine that we create this component attached to the window to set the properties and function that needs to handle the click on the button. So this class is like the code behind for the user interface. By using this framework, the function we want can be used in Revit as a plugin to help users automatically find the relevant information by different targets in BIM projects, which can save BIM users time of finding target information, reduce omissions, increase the accuracy of results, and allow them to work on more important design tasks, contributes to enhance productivity in the AEC industry. Thank you for listening.